problem, please let me know. Okay.
This conference will now be recorded.
Yeah, hello everyone, good morning. So let's start our today's session, and hopefully you are able to see my screen, right? If you have any problem, please let me know. Okay, you are able to see my screen. Someone can confirm if you are able to see my screen. Okay.
Yes, sir. We are
Okay,
able
thank
to
you.
see your screen, sir.
Yeah, thank you. So now let's go ahead, and first we will be having a quick recap over here what we have discussed in our last class. So we have seen that we are having three types of table: transparent table, pool table, and cluster table. In transparent table we are having one-to-one relationship, pool table we are having many-to-one relationship, and the cluster table we are having many-to-one relationship. In pool table and cluster server, both is of having same kind of relationship, many-to-one. Many-to-one means many pool table at application server layer, and single table, that means the table pool at the database layer. Here also the same thing at for the cluster table. We have to today define the difference between this transparent pool table and cluster table. Okay, some concept it was yet to explain, that's why I didn't write it over here. Today we will do so. Okay, we also understood the foreign key relationship or referential integrity, or like how to define the check table. This concept we understood in detail in our last class. We understood what is the client, what is the meaning of client, what is the meaning of client independent and client dependent. Okay, and then I have given you some assignment over here to complete. Fine. So if you'll be having any doubt, at the end of the session we will try to explore that doubt, and I will try to answer your question. Fine. So let's start our today's session, and in this let's go ahead, and just a second, let me share my screen. Okay, so now I'm just sharing my fine. Let's log into SAP Logon, and okay, so let's go to SE11 transaction for the data dictionary, and here yesterday we have created a check table, right? And we have created a table maintenance generator as well. Okay, so we were having two tables over there, if you remember, right? So ZMB28 student, this was the main table, and if you click on the content button, okay, it will show you all the content once you click on this effect button. So after execution we got this contents over here. Okay, and for this, for the main student table, we have created the table maintenance generator. Okay, just a second. Okay, so here you can see that we are having the content just we have seen, and we are having another table as well that we have created, that is the mobile number table. For the student mobile we have created this one. Okay, today we will see how we can create we will see the concept of indexing. What is actually indexing? Okay, so let's go ahead and see how we can create the index, what is the meaning of indexing, and how it behaves in the system. Okay, so maybe I will go to the PPT, and here you can see that for indexing, let me write down here the indexing. What is indexing actually on any table? So on any table, the meaning of indexing means, suppose if you are having a table called a Mara table, that is a large table, that is a standard table, right? So if you come over here and give the Mara, click on this display or press F7, click on this content button, and if you see, it is having large amount of data. As of now, you were able to see only 200 initial entries, but in fact, if you click on this number of entries, you can see it is having 22,847 data. So in real time, it can have more data as well. Or suppose if you have some, transactional table, for example, BBAP. Okay, this is a transaction table. Okay, it holds the data, transaction data, sales document item data. Okay, so VBAP, it's a transparent table, and its name is VBAP, and it is having the transactional data holding over here. If you see the content for this table, there will be, you can see 27,425, but in real time you will get like lakhs of entries over there. So suppose if you have to search some entry from some table, how you can make it fast? Because if you are having a lot of number of data present in the table, it will take time to retrieve the data. Okay, so for that purpose, indexing come into the picture. Okay, for example, suppose if you are having a table, I'm just taking one simple example over here. Okay, uh, any transaction table, because why I'm telling transaction table, because it is having large amount of data generally. Okay, so let me take the example of BBAP table. Okay, so VBAP table, we are having this VBAP table, a standard table, and it is having like purchase order field, then purchase order item, maybe you can define over here the item, and here the material for each item, or each item represents a material. So main purchase order item and material you are having, suppose one here, 1, 2, 2, and maybe 3 I can give over here. The item I'm just giving 10, 20, and here again 10 and 20. So item 10 means the single item, 20 means the second item. It's just a representation in a SAP has been done like this. Okay, like that. So 10, 20, and again like 10 we can say, and some material over here, maybe laptop, mobile, right? We are having again the laptop and mobile. We can give or something, some different material also can be given over here, right? Pen or something like a book. So different kind of item we are having. Suppose this is a large table, and if you want to search a entry over here, for example, you want to search a purchase order with 2 and the item with 10. Okay, so the key field here, maybe you can define this 2 field as a key field. Generally this 2 field comes as a key field in the VBAP table. If you go and check, you will be able to see over there. So this is the key field, just I have denoted with this. So now your requirement is to search the data based upon the purchase order and item. So because this is already a key field, what the system does internally, you might have heard about, if you are from the database background, you might have heard about that. If there is something key field, the searching is very fast over there if you are going to search any record based upon the key field. So searching is going to be fast. Why? What is the reason? If you are going to search any content based upon the purchase order and item, why the searching is going to be fast? The reason behind system itself, you know our application server database abstraction layer, whatever we are having, which is responsible to convert our OpenSQL into the native SQL, or OpenSQL into their native database language. That system, or even the database system itself, what it does, if it sees that in a table, if there is a primary key, it create an index. So what is index? Based upon the primary key, automatically it creates a index. So whatever the index gets created based upon the primary key, this is known as the primary index. Okay, this is known as the primary index. So here you are having the purchase order field and you are having the item. So based upon the purchase order and item, automatically by default the primary index gets created. So meaning of index means the data in the table gets sorted based upon purchase order and item. And if there is something sorted, it's very easy to identify the data, because you can put the binary search over there. You can apply the binary search over there. So internally system can apply the binary search. Okay. So, so what happens? The system creates a extra memory, one extra memory reference creates for this two particular, suppose the primary index is going to be created for this two field. Okay, for these two fields is going to be created, then there is some extra memory in the system, kind of temporary memory we can say, and there the system copy this primary field content over here. Okay, I'm just going to paste it over here, and the two key fields, and it just sort it. It just sorted. Currently you can see it is already sorted over here, 1 1 2 2 3 3, based upon purchase order and item. It's sorted over there, and it creates a reference. Okay, it creates a reference for the first record, for the second record, okay, for the third record. It is having the reference over there. So whenever you will start searching anything, what happens? System does not start searching over here on this table directly. First it looks into the first it looks into the index table. So this is your index table, and for the system it's very easy to search in the index table. As you have seen, when we are having any book, okay, so at the last of the book we are having the indexing done over there. So if we have to search any word or any keyword, so we go last of the book and we see that particular word over there. It's easy for us to identify that particular word, because we know that everything is there in the sorted order, and we quickly find out that particular things, and from there it gives the page number, and with the help of the page number we go to main book and we see our content. That is known as the index over there. The same concept here also it applies. So it creates a temporary memory, and it takes the all the key and it puts into the sorted order, and it creates a reference. It creates a address reference. It creates a memory reference of the actual record. And when you are going to search the primary index, when you are going to search the temporary memory, okay, it's very easy for the system to search over here. And once for example you are going to search the purchase order 2 and item 20, okay, the system what it will do, it will quickly find it out over here, and system also know this 2 and 20 where is in the actual database, and it will just see that this 2 and 20 is pointing out to this 2 and 20, and it will get quickly that data and it will show you the result. So that's the benefit primary index. But the primary index can only be automatically gets created on the purchase order and item, whatever the key field is there. But suppose if you have to search based upon the purchase order, item and material, right? Or maybe I can show you, you can see this BBAP table is there. Okay, so this is the sales document item data, or maybe we are having a table called EINA. I think it's for purchase info record. Okay, so can anyone tell me that what is the table of this purchase order? EKPO, yeah, I just remember, I'm just missing it. So this is the purchase order item table. Okay, EKPO, and here you can see that EBELN stands for purchase order document number. This is the header, purchase order number, main purchase order number, and EBELP, this is the item number. And if you click on this, you can see the content has been organized like this way. This is the client. By default it is coming, right? If client is coming, that means this data you will be able to see. Whatever data you are seeing over here, it will be visible only in 800 client. So by default, this 800 client is will always come under the key field. So you don't have to bother about this. I'm not going to consider this mandate field every time. Okay, other field, let us consider this EBLN purchase order. This is the main purchase order number, and EBELP, this field is the item number. That's what I was telling you, 1010. You can see here for the single purchase order, only single item is there, and if you want, you can see the material over here. Okay, so, and there are so many fields. So you can see this field, and this field, MANDT, EBELN, and EBELP. Okay, this one you don't have to consider. System automatically will consider every time this is a key field. Mostly this EBELN and EBELP, I'm going to consider this one. System will create a primary index based upon this. Okay, and when you are going to search based upon the primary key, it will be very fast. But suppose if you have to search the data based upon, suppose this material number and this EMATN, some field is there, or BUKRS, these three fields you will have to search the data, right? So on primary index, it is fine. If you will have to search, system will be fast, right, to search, because the index has been created. But here for this field, which is non-key field, index is not there. So in this case, to make the search fast, because if you are going to search over here, it will be difficult for you to search the data based upon the material number, EMATN, and BUKRS on any non-key fields. If you take any non-key fields, so suppose if you have some requirement where you are going to frequently access the data from the table in your program based upon this material number, this field, and this field, what you can do, based upon these three key fields, you can create a secondary index. Okay, you can create a second index. So how you can create a secondary index, I will show you. For example, in this EKPO table, you want to create the secondary index based upon material number, EMATN, and BUKRS. So it will, when we are going to create the secondary index, it's very easy to create over here. In backend, what the system will do, it will create a temporary table, and in that temporary table, all these three fields will be put over there, and it will be sorted. Okay, in the sequence, MATNR, EMATN, and bookers. And whenever you are going to search any data based upon this, it will search from the temporary table and takes the reference to the main table, and it will show you the data whatever you are willing to see from here. Hope it's clear for everyone. If any doubt, please let me know. Okay, so here I will create a secondary index. Okay, if you have any doubt, you can write your question in chat box. Okay, if you are not feeling comfortable to unmute your mic and ask the question. Okay. Fine, so here I will show you how you can create the secondary index. So here you can see one button is there. So I will show you here. You can create the secondary index for custom table or a standard table. Any table you can create. So maybe I can take this custom table, our table, right? You can go over here, you can click on display, and you can come to this screen, click on this index button. So you can see as of now there is no secondary index, right? Automatically on this student ID, primary index has been created. I have to create the secondary index now. Suppose in some of the program I have written a lot of query based upon this age. Just I'm taking one example based upon this age, or suppose based upon this first name and last name. and a lot of data, a lot of millions of data is there in this transparent table, and system is taking time to get the data. So what I will do, I will create a secondary index. Unnecessary, we don't have to create the secondary index. It will be having a problem. If we are going to create unnecessary secondary index, more than 9 secondary index, somewhere you will see in SAP documentation that more than 9 secondary index is not recommended to be create it. So again, it depends on version to version of the SAP. Somewhere I have seen that more than 16 is not recommended to create. Okay, secondary index. So let's suppose 16 maximum, we cannot create more than 16 secondary index. Means we can create, but we are not supposed to create more secondary index. There will be problem. What will be the problem? I will let you know. As of now, let us see how we can create the secondary index. So I know that this particular field is getting accessed quickly, means many times in my program, and if I'm going to create the secondary index, it's going to create the performance. So what you can do, you can create the you can click on this create button, and you can click on this create index. So it will create a secondary index for you. You have to give the name of the secondary index over here. For example, Z01 I can give. Click on this OK button. Okay, and here I can write the secondary index on first name and last name, and then here the field you can give over here, the field on which you want to create the secondary index. Press F4, you will see all the field over here, right? First name and last name I want to, so just I'm selecting the first name over here for the first field, and the last name I'm selecting over here. So it all depends on your requirement, how you want to do, right? So first name and last name is there. So because I have seen that there are many select query with in that the searching is there based upon this first name and last name. That's why I'm creating this secondary index. Just save it, that's it, and activate it over here. Okay, just to go back, your index got created over here, and index of the name of the index is Z01. So now you don't have to specify something like that you have to use this secondary index. Suppose in your ABAP program there are a lot of select query, and wherever the searching is there based upon these two fields, system automatically look if there is some secondary index created or not. So if some secondary index is created, system will just go from that secondary index and pick up the record, and with reference to that report, it will go and get the data from this particular main table, as I have shown you in that PPT slides. Okay, so this is actually the secondary index. Hope you understood, right? And similarly, like if you want to create the secondary index based upon the age, right, in your program, like you are having the there are many select query. If you are having some 1 or 2 select query, and if your performance is not that much bad, then you are not supposed to create the secondary index. Okay, secondary index, what will be having the problem if you are having the more secondary index? Suppose by default you are having this primary index, you cannot avoid this one, right? But if we're going to create some more than 9 or 10 or more than 16 secondary index, in that case what will happen, if we're going to do any modification in the table, modification means modification in the record of the table, right? So for example, this is your table, and if we're going to like this material description, or suppose this material you are going to change it over here, system has to adjust their secondary index based upon if we're going to change here some field, or maybe whatever change you want to do, you can do over here. The same change must be reflected in that temporary index also, whatever the primary index you have created. Suppose 2 or 3 or 4 secondary index you have created based upon this item, and suppose item and material, combination of item and material, you have created some secondary index, right? Based upon some material and some another field, you have created the secondary index. So wherever if you do any change over here, right, then that changes must be reflected in that secondary index as well, and for that database has to perform a lot of operation. Database has to perform a lot of effort. Okay, and that's why instead of gaining the performance, it is like overall impact on the database you are not going to achieve in terms of performance when you are going to create the a lot of secondary index on a existing table. So maybe you can note it down these terms. If like more than secondary index, let me write it over first. Secondary index, right? So by default primary index gets created on the primary key of the table. Okay, now if you want to create the secondary index, you can create the secondary index based upon the requirement. Now if you have multiple searching performs, multiple searching perform means multiple select query. Okay, multiple select query. We will see in our report how the select query is. Okay, if you have multiple searching performed on the database table, on the non primary key field of the database table. For the primary key you don't have to bother because already primary index will be there. So if you have multiple searching performed on the non-primary key field of the database table, then you can create the secondary index. Okay, secondary index in order to improve the performance. Okay, more than 16, somewhere I have seen 9, somewhere 16, based upon the version, what version of the database, what kind of database you are using. Okay, so all together I'm taking 16. More than 16 secondary index is not supposed to, you can create, system will not stop you to create, but more than 16 secondary index is not supposed to create, because more secondary index overall can hamper the performance, because if you do any changes in the record of the database, database has to adjust the secondary index, all the secondary index, actually all the secondary index, all the database has to adjust all the relevant or all the connected secondary index accordingly. So that's why we are not supposed to create more and more secondary index. Whichever is required and whichever you feel that it's very important, that's only we are going to create. Now let's come over here and we will see the difference between, we will note it down, the difference between transparent pool and cluster table over here. So in transparent table, you have seen there is a one-to-one relationship, between application server and database, right? If you come to the pool table, you are having, why I'm telling, because these are the very important interview question. Whatever we are writing over here, I'm writing because these are the very important interview question. Please understand, like you will get, this is very important interview question, what is secondary index and why it is created. Okay, again, what are the different, what is client dependent and client independent, right? Everything whatever we are, what is this check table, what is the foreign key relationship, so you must have to understand the concept in detail. Okay, what is this pool table and cluster table? So if you don't understand, please stop me and ask the question. So all these are whatever we are noting down over here in this particular slides, everything is important from interview point of view. Okay, everything is very important from interview point of view. So transparent table, pool table and cluster table, so you will get the question from your interviewer something like that: how many types of table and what is the difference between them? How many types of table and what is the difference between them? Okay, so the transparent table you saw, and here the many to one relationship, you have to tell that transparent table is 1-to-1, cluster table also here many to one relationship, many to one relationship. So many to one, so when you tell the many to one relationship, he will tell what is the meaning of many. You have to tell many means at application layer there will be many table, so application layer you will be having many table, and at database layer you are having only one table. Okay, database layer you are having only one table, and that table name is actually table cluster, that is known as the table cluster. Okay, that single table. Many to one relation here also. So in case of pool table, that is a table pool, that one table is table pool, and in this cluster table, that one table is known as the cluster table. Yesterday we have seen, right? Many to one. Here also many means application layer, and here one means database layer. Hope it's clear for everyone. Good. Now the second difference is that on transparent table, you can create the secondary index. Primary index is already there, you can create the secondary index. Here you can create the secondary index, but in the pool table and cluster table, no secondary index can be created. No secondary index can be created. Why it is not created? Because this pool table will not be there in the database layer, right? It will be at the database layer, you are having the table pool, right? You are not having the pool table. That pool table does not exist at all at the database layer. You can see over here, for each pool table we are having the single table pool in which all these pool table are clubbed together, right? That's why, because there is no single pool, there is no one-to-one relationship, as here you can see in transparent table we are having, you can see over here, right? It is not the case for the pool table and cluster table. That's why we will not be able to create any, no secondary index can be created over here. Similarly, if you can come over here, no cluster table can be, no secondary index can be created over here. So this is the second important difference. No secondary index can be created over here. Fine. Third difference, the very important difference is that, here on the transparent table, you can apply open SQL plus native SQL. Native SQL means the native language of the database. Okay, this is one part of the language of the database. So both is applicable, both can work over here. I will let you know in coming classes what is this open SQL, native SQL. Once we will go into the report part, there we will see. Okay, here it supports only the open SQL. It supports only the open SQL. So because open SQL supports all the table which has been there at the application layer. Okay, all the table. So here you can see transparent table, is there at the application layer as well. That's why OpenSQL is supported. And transparent layer, the same table, the name of the field, the table name, everything is there at the database layer. That's why native SQL is also supported. If you come for the pool table and cluster table, this is not the scenario. The pool table only exists at the application layer, and the cluster table also only exists at the application layer. So that's why only you will be able to use OpenSQL only, no SQL. Okay, no SQL. Here also, you will be able to see OpenSQL only, no SQL. Okay, so this is the important. Transparent table, generally we use these to store the master data and transaction data, right? Master data and transaction data, that means application data. That means it is used generally to store the application data. Okay, but if you see for the pool table is used to store the system related information. That means if you have defined some parameter, just let me note it down, system related information, for example parameter, you having screen sequences. Okay, so such kind of things, it will be match code. You can tell that match code objects. Gradually you will be able to understand all these things. At this point of time maybe you will not be able to understand this parameter, this screen sequences, this match code object, but just to understand this is a system related information, and in coming classes you will able to know. As soon as our class will proceed further, you will be able to understand what is the screen sequence, what is this match code object, what is the lookup value. Okay, lookup value or drop down value also you can tell. Okay, drop down values. Okay, or maybe you are going to create the secondary index. Whatever you have created the secondary index, where it gets stored. Okay, so such kind of system related information gets stored in the pool table, where the where the tables are actually I will create one pool table and let you know like how it looks like. Okay, and how it is how the many small table are connected together in this pool table. Okay, cluster table, if you see here, it is used to store large number of continuous record, large number of logically related continuous record. For example, if you have some document, okay, if you have some document from for different business requirement, but specific to some process, okay, same process but for the different requirement. So these are the logically related records. So of logically related continuous records, for example document, any kind of document you can see. And these are very big table actually. These are very big table. This cluster table, these are the very big table. These are small tables. These are small tables, and these you can categorize like medium table. Okay, medium table you can see. So pool table, all the pool table like 10-20 pool table can be clubbed in a table pool, and all the pool table will be a small table. In cluster table, 10-20 cluster table can be combined in a single table cluster. All the cluster table is going to be very big table. And why it is used to cluster table? It is used to compress the record. Why this concept come into the picture? Why we didn't use this transparent table? Okay, why for pool table the transparent table was not used? Why the pool table came into the picture? The reason behind the pool table, or let me first show you the cluster table. The reason behind this, because if you have to store large number of records, large amount of data in transparent table, suppose if it's going to take 10 GB of memory, here it will take only 1 GB or 2 GB, something like that. So 5 to 10 times compression can be achieved over here. 5 to 10 times compression can be achieved in the cluster table. In the pool table, what happens that if there are many small tables and all the small tables are application specific, and if you have to get all the data together at one time, and if you want to get the performance also optimized, in that case, you require this pool table. So all the data at application, application layer to get at one time. Okay, so this is the requirement here. There was no such requirement in transparent table. It's a simple table, but the most widely used table is this one only, transparent table. It's a simple, it's easy to use. There are a lot of benefit of this transparent table. If both the scenario you don't have to achieve, if you are having the normal scenario, simple scenario, and most of the time we are having the simple scenario only, the general scenario only. So in the general scenario, like if you have to just put the data, okay, like application data, master data, or transaction data, you can go for this. Okay. Fine, good. If you have any question over here between this transparent pool and cluster table, these differences, there are, most of the interview they can ask what is the difference between this, and you should be able to give at least two differences, the first and second, or at least the first three differences. If you are able to tell, it will be good. Okay, fine. So let's go ahead, and now I will show you how you can create a pool table and cluster table. Okay, so to create a pool table or cluster table, first you have to create a, let me start with a pool table. Okay, so to create a pool table, what you will have to do, you have to go to utility, and here you can see that you are having the other dictionary object. Click on this, and here the second option just to select over here. So Z MB28, this is our prefix which we are using for this class, and pool table. So table pool I'm just creating, TP table pool. Click on this OK button. Okay, and sorry, I did mistake. Okay, go once again to this utility, go to other dictionary object and select this one and click on this create button. So you will be able to create the table pool over here. Okay, though nowadays this table pool and all is not like I never created in real time, just for demo purpose or just for this training purpose. I have learned about these things, but never I have created in real time. Most of the time we are going to create the transparent table. Okay, transparent table is the mostly used, but we should know what is this pool table, what is the cluster table, why it is used, but never I faced any requirement in 10 years of my career to have such kind of things over here. But let us see. So if you have to create the table pool, what you have to do, that you have to uh, uh, if you have to create the pool table, first you have to create the table pool, and table pool here, like you can give some description for this table pool. Table pool demo, right? And here automatically you can see that tab name, var key, data length, var data, right? You can see this table name, var key. So I have shown you, like if you have the multiple small table, you are going to store in the table pool, right? So let me open an Excel over here, and you can see that in this table, for example, you have some table 1, pool table, pool tab 1, and in this pool tab 1 you are having some data, right? So maybe I can merge and center it over here, pool tab 1, and you are having pool tab 2. Okay, this also maybe I can merge it. Okay, so here are we, and you have for this pool table 1, for this table 1 you have the key something like this, and the description or maybe some another. So here you are having the key field for this particular pool table. The first field you can consider like a key field. The second field may be any field, like something description like that. And here also for so just let me give that key 1, and here this key 2, right? Another table I am having, and this another table is having the field key 2, and here also the description I'm having something like this. Suppose you are having the 2 table. Okay, this is the table name, and maybe let it be little descriptive. Okay, instead of key 1, I'm just going to mark this field 1. You are having field 1, you are having field 2, and then suppose you are having the field 3 over here. Then come over here, FIELD, field 1, field 2, and then field 3 you are having, right? In this pool table 1 and in this pool table 2, you are having these 2 fields, as a key field. Let us suppose if you are having this 2 key field as a field, just I'm highlighting it. Okay, or maybe I can give some color also over here, just to make sure that this is the key field. And here also, maybe here only you are having the field, the first field as a key field. Okay, just to differentiate the field name, I'm giving the field 3 over here, I'm going field 4 over here, and field 5 over here. Okay, now what will happen, as I have told you, all this pool table 1 and pool table 2 is going to be stored in the table pool. So for example, this is your table pool, and maybe I can go to the home and wrap text, merge and center, and I will give the table pool over here. So this is at the data dictionary level. In the table pool, everything is going to be stored, right? At the data dictionary level, everything is going to be stored at the table pool. So in table pool, because all these pool table you have to store at the data dictionary level, right? So how you can store this pool table 1 and pool table 2, right? So here you should have some key field, right? Or maybe you have the table name over here. So in this table pool, you should have the table name over here, first field, right? And then you can have the content. Maybe I can give write the content over here, right? So just I'm giving the high level overview so that you will be having some idea. Okay, so here you are having the table name, and so maybe, and here also you can have like this, fine. So here you can keep the table name 1, right? So you can give the pool table 1 here, right? So in database also it will be stored in some table, right? It will be stored in some table only. So table name I'm just giving the pool table 1, and the content, whatever the content over here, right? For this pool table you are having, what is the content? This key field you are having, and then this description is there. So this 2 key field, field 1 and field 2, this will come over here in the key field, right? So field 1 and field 2, FILD field 2, and the content you can put in this content, right? Field 3. So this is how. Similarly, the pool table 2 gets stored over here, right? Pool table 2 will come, and the field 3, this is the key field, and another field under content will come field 4 and field 5, right? So like this is a high level view I have just given. You can just think that you have to store this table in a big table. So to store the big table in a big table together, how the structure should have, right? So you have to give the table name, and for each table name right? To differentiate their record, you must have to give the key field also, right? You must have to give the key field also. So overall, how the structure will look like, maybe you can remove this one and I will tell you over here. Just to go to and merge and uncenter here. So here it will be table key, and here you are going to have the key, right? And here you can give the content. So the pool table one, you can put it over here. Just copy this one. So table name you can put it over here, and the key is what? Field one. So you can just copy this field one over here, and the content of this field 3 can come over here under this content, right? Similarly, suppose you have some another record, maybe, right? For this field 1 and field 2, the record will come under this, right? Hope it's clear for everyone, right? Pool table and pool table 2. Suppose if you have some record over here, that record where it will come in this format, just I'm defining the table. It's a structure of the table, right? So the pool table 2 if we are having, so the pool table 2 will come over here, and then field 3 will come over here, right? And the field 4 and field 5 is content over here, field 4, and then field 5 you can write it like this. Okay, so what are the field you require? The table name you require to store this table name, then you require the key to store the key of the table, and then the content you will require. So the structure should look like something like this: table name, key, and content. And that's what it is here in the pool table. You can see the table name, this is the key, and this is the content, and this is the length of the content, how much content is going to be put over there in this table pool. Okay, click on this activate button, local object. Okay, and it has created the table pool. Now, okay, size category it is asking, so go to technical settings and give some size category over here, because this is also ultimately a table only, but not here at the database layer, right? So just I have activated, and now the structure of this table pool is like this: table name, var key, data length, var data, and in this our pool table is going to be stored in this table pool. Just go back and we will create now pool table. So this is the table pool. Okay, this is the table pool, and now I'm going to create ZMB28 underscore pool table 1. Pool table 1, click on this create button, and here pool table 1. And the delivery class you can select A. If you want to maintain the entry and all, you can use like this. Technical setting you can go yes. Local object, you can give the data class, size category, click on this save button. Okay, just go back and you can give some field, whatever field you want. So mandate will be, just give as a standard practice MANDT. And for example, suppose if we're going to, I'm going to create a pool table for a student, though it is not a real-time example, but you know, just I'm giving you the idea, like it stores the system information. So maybe let me be in real time. So parameter, right? First field you are going to store for the parameter value. Okay, but at this point of time it will be difficult for you to understand this terminology, so just I'm giving here something like, you know, just to make you understand. Suppose a student ID is a system field. Okay, so a student ID I'm just going to give, because pool table generally stores the information related with system. So a student ID I have just given. Data element you can give. Okay, for the student ID, what is the data element we have created? This is data element we have created. And similarly the age and whatever you want to do, you can give over here and you can select. Okay, and just save it. So this is the, currently it is a transparent table. I want to mark it as a pool table. So what you can do, you can go to utilities, or maybe I think you can go to extras, and you can see the change or display table category. Click on this button and you can see here you are having the option. So by default it is a transparent table, but what I want to make it, I want to make it pool table, right? And similarly, suppose if okay, for cluster table maybe I will show you later. Okay, so pool table I have selected from here, and in case of HANA database, what happens? It is now not comes under the better practice. Like in case of HANA database, most of the pool table and cluster table has been converted into the transparent table. HANA database does not appreciate to use the pool table and cluster table at all. Okay, but you can use. There is means there is no stopper kind of things, but as a SAP standard guideline, we are not supposed to use pool table and cluster table. We have to avoid as much as possible, right? The pool table and cluster. However, in the real-time scenario, also without HANA database, I have never created the pool table and cluster table, right? In case of HANA database, right, it is, I don't think so. Like for maybe for SAP as a standard development, they might get to create, but for us transparent table is sufficient. Okay, but in case if you have to create the pool table, this is the way how you can create. So I'm selecting this pool table from here, click on this OK button, and now you can see here it got changed and now it became your pool table. Just save it, check the syntax, and here there are some lot of error is coming over here, right? You can see this is the error. So the first error, if you see, the pool or cluster is not active, means whatever we have created the table pool, that is not active, right? Let me do one thing, go to this attribute or delivery and maintenance. Here you can see it is asking for me to provide the pool table. So I have already copied that one table pool which I have created. So the pool table or cluster, the table pool or table cluster, whatever you will create, you have to give over here. Now just save it, and now just try to check the error. If it is, there is no error now, right? Only warning, you can ignore the warning. Now you can activate and your pool table got created. Similarly, you can create multiple pool table. Okay, pool table 1, pool table 2, click on this create table. Here you can give some description. Okay, any description you can give. You can select the delivery class. You can similarly you can create multiple pool table, and again you can give the field and all whatever you want. And once you come, you go to extra, you change here, change display category and all whatever based upon pool table or cluster table. Just follow the same step for the another pool table also. I'm not going to create. Okay, similarly, if you have to create the cluster table, first you have to create the table cluster. So go to the statement over here, utility, other dictionary object, table pool or table cluster. Here I'm going to create the table cluster, TC. I'm going to create the table cluster, right? Click on this OK button. Sorry, I missed to click on the create button. Go and click on this create button. Okay, and table cluster, here the second option you have to choose over here, and you can see automatically this format got created. So table cluster, and similar way, here just save it over here. So in table cluster, why this is different from the table pool, if you can see over here, right? So just to understand, this is for the purpose of the logically related records. So if you have to put the different records from the different table, which are logically related, for that purpose you will require such kind of a structure. So this var key is nothing but your key, right? This page number means because if in one line you are not going to accommodate that particular content, you are going to the next line, and the timestamp when you have created that particular record. This page log, again like the change log, and here the var data, that means the content. So in this format you will have to store the data if the data are logically related. Okay, just save it, and here go to the local object, activate this one. Okay, and that's it. I think it's fine. And again you can create the table cluster. Okay, so pool table, cluster table, CT one you can give. Click on this create button, and on the cluster table, fine. delivery class, you can choose over here a table maintenance allowed. You can give the field name, whatever field you want. For the transparent table, this will be the same as in the transparent table, as we have created the student table, a student mobile table. Similar way you have to create. Once you create over here, again you can go to extras, you can go to, you know, change table or table category. You can give the cluster table over here, and whatever the table cluster you have created, that table cluster name you have to give over here. TC I have created, press enter, and you have to save it, and you have to this time it will give you the error because I have not given any field over here. Maybe you can give one field over here, right? And here also you can give maybe a student ID or something like that. Just save it. Now it will not give any problem. Generic key field must be from the logical cluster var key. Okay, so if you everything mention over here, you know, then it's going to get activate properly. As of now, let's not give more time because it is not important. Also, just in order to, you know, from interview point of view, I have made you understand what is actually this pool table, cluster table, what is the differences. In real time you are not going to use this pool table and cluster table. It's a very rare. I have never used till now. Save it. Transparent table is the most widely used table. Mostly we are going to use this transparent table. Okay, fine. Let me go to create one another slides, and here we will discuss something about the buffering concept. Okay, so when we create any table, okay, when we create any table, for example, I have created this table, okay, and you have, if you go to the technical settings, you can see here we are having the buffering option, right? Buffering not allowed, buffering allowed but switched off, buffering activated. Why this buffering come into the picture? See, everything is running around the performance only. Everything is going to, you know, going to like ABAP or any technology. If you come to any technology, so like we mostly bother about the performance, right? So here also this buffer concept is also related with the you know, related with the performance only. So for example, if you see our R3 architecture, this is our R3 architecture. Let me copy this complete slides, and what I will do, I will paste it over here. Okay, so I'm having this, you know, application server layer, right? Just I'm going to remove this. Okay, and this we are having the database layer. Now whatever the database you create, right, whatever the table you create, where it gets stored, or the physical data gets stored at the database layer, right? You already know these things. So this is our application server, and fine. So the actual table gets created at this database layer, and application server is having the program logic and everything to fetch the data from the database layer and represent to the user layer, right, on the SAP GUI. This is having this where actually we write the logic, we'll write the logic at the application layer. So whatever the program, for example, if you create one program, or if I tell you the existing program, so for the program we are having the transaction AC38. AC38 is the transaction. /n or /o, if I am giving over there, that means I'm just trying to rephrase this one and create AC38, right? If you simply give AC38, nothing will happen. You can see nothing is happening, right? Simply if you give AC38. That's why I give /n. That means just terminate this session and create a new session for me, and there you open the transaction AC38. That's why I'm using /n. And if you want to completely open a new session, I can use /o. Okay, I don't want to open AC38 on the same session. I want to open AC38 on the different session. I can use /o. So as of now, just I'm using AC38. You can use anything, AC38 or /o AC38 or /n AC38. But the main T code is this one, AC38. Okay, click on this enter button, and you can see the program has come over here. Just I'm going to take one program over here. Press F4, right? Take some program. someone has created this custom program, right? So you can see whatever we have written on the presentation server layer, you can see this is the presentation server. So this ABAP editor is at the presentation server, but actually once you activate the code, right, once you activate the code, once you save and you activate in ABAP, everything goes on the application server. Okay, behind this presentation server you are having a big computer. There is a very big computer from which there are a lot of presentation server connected, and once you activate, the code goes inside the application server, and when you click on this run, the code run on the application server, not on the presentation server. This is your presentation server. Code does not run on this presentation server, but the result you are getting on the again presentation server. The data, this processing of data is happening on the application server, right? Similarly, here you can write a code, and in that code you can write a select query to fetch the data from the, for example, if you want, you can write the select maybe some from Mara table or from our table if we want to get the data. Okay, so what I will do, that maybe I will show you. Just go back and create one program, a small program, Z something like MB28 buffer, just to explain this buffer concept, test and executable program save. So here, you know, you are going to write some select query. What this select query you are going to write? Select a star from Mara into some table, and you can give some container over here to store the data, which data is coming from the database table, right? So here your data will get stored on this application server. So when you are writing this select star from Mara, your data is going to fetch from the Mara table, which is there on the database layer here, database layer, and it will put onto this application server layer. So you are writing the query actually over here, select star from Mara. So system has to take every time data from here and to store over here or to process over here. But what if the frequently used data, you know, the frequently used data, instead of going every time to take the data from database layer, if you put some data over here itself directly, right? If you can create some memory, temporary memory space, and this temporary memory space is actually known as the buffer. Okay, so the frequently used data you can put into this buffer, so that system has not go to this database layer and the network, because every time when the application server is going to connect with the database layer and the communication happens between these, there is a latency, right? It has to come over here, the command has to fetch the data, and again it has to travel through this particular pipe, and it has to go over here. So this time you can save, you know, and also, you know, the performance on the database layer is little slower than the like if you if you are going to do the any operation on the application server. In case of HANA database, you can understand like an exception, because HANA database is an in-memory database. There you may get the better performance than the application server. But in general, if you are not having the HANA database, other than the HANA database like Oracle, MySQL, which is not a in-memory database, okay, that means which is not installed in a RAM level, which is installed at the hard disk level like Oracle or MySQL or Sybase or DB2 or DB6, any non-HANA database. In that case, even for HANA database also, it is this buffering concept is there, you know, because this turnaround time, the network time is going to impact the performance, right? But in buffer, if we are going to get the data directly from the buffer, which is frequently used data over here, you know, your performance is going to be fast. That's why the buffering comes into the picture. Okay, so the frequently used data you can put into this buffer. Now let me open one more slides. Okay, so here if you see, you are having the different kind of buffer. So let me note it down here. So you have buffer three types. You have three types of buffer. Okay, so first you are having the single record buffer. Second, you are having the generic buffer. Okay, and third, you are having the full buffering or full buffer. So three kinds of buffer you are having: single record, generic buffer, and full buffer. Why this concept come? Like, so this concept come because suppose if you are having a large table, right? If you are having the large table and that large table, right, is not frequently accessed, and though if it is frequently accessed, some particular records from that large table is only going to be accessed frequently, right? Suppose you are having 10 fields over there in that particular, in that for example, maybe I can show you over here. Go to some table, and maybe this is our table. Run this, and you can see in this particular table, right? If you are going to just assume if this table is very large table, and just you are going to access this Ram Kumar record, the record number 3, very frequently from this large table, you are going to just access only the single record very frequently, not all the record. Something kind of requirement like that, okay, you are having. So come over here, go to the slides. So, if you are having the large table, and if you want to put into the buffer that large table, the complete table, if you want to put into the buffer, what will happen? It will take a lot of memory. Your application server will be having the lack of memory because that database table that is having the large amount of data, right? So the full buffering, that is the concept of actually full buffering. All the data from the table you are going to put into this buffer, all the data, right? All the data you are going to, if you have some Mara table or any table, you are just going to, if you have enabled the full buffering over there, all the data from Mara will go and come over here. So again, from the next time if you are going to access the data, it will directly access from the buffer, not from the database layer. Okay, so your performance will be fast. But there are many, if else, there are many things you have to consider, right? For example, suppose tomorrow your data is going to be changed over here at database layer. The same data, the same data is not reflected over here, because in buffering, whatever the data got changed over here, it must be reflected over here. Then only you will get the correct result, otherwise you will get the wrong result, right? Your latest data must be in sync with the buffer. And suppose if you are having the large table, every time syncing through this network is again going to be performance, it's going to hamper the performance. That's why we have to be very careful when we are going to enable the buffer. Okay, when we are going to enable the buffer, that means when we are going to select this buffering activated, you have to be very careful. If you are not confident, never use buffering. It's going to give you wrong result, it's going to hamper the performance. So it's never suggested if you are very new to this technology, right? And if you are not enough confident, right? If you don't know end-to-end scenario of the buffering, it's always recommended just use the first option, buffering not allowed. That's fine. It's not there will be no any problem, right? There is no problem at all if you're not using. Instead of for getting just little performance, if you are going to hamper the system, if you are going to get the wrong result, that is not at all recommended. So if we are not if we are not good mature to use the buffering concept, it's always better just let us use buffering not activated. However, as a ABAPer, we are like when we are going to choose this buffering option, generally we put a meeting with our team members, we put the meeting, our basis guy or database admin guy, we understand the nature of the data and everything gets defined. then only we are supposed to use the buffering. Okay, and also while choosing the buffering, you have to take care of many things. For example, as you have seen that if your data is going to get frequently, if your data is going to, if your data is going to change frequently, right? If your table data, for example, the transaction data, right? If you are having some transaction data, okay, like any purchase order value, right, or something like that, which is going to get changed every time. So if your data is going to change frequently, then never use buffer. Never use buffer. Why? Because every time system has to sync the data in order to get the correct result. Database administrator has to keep on eye, right? So the maintenance and everything is going to be very costly. So never ever use this buffering mechanism. Okay, so like I can important point I can write under this notes. Okay, so where you can use the buffering, where you can use the buffering, where you can use the buffering. Now this is the question. Okay, so the answer is, if your data is very rarely changed, is very rarely changed. If your data is going to be changed very rarely, this is the first scenario, right? Second scenario, so this is the most important scenario actually, and now the scenario is going to be the buffer wise, right? So single record buffer. What is the single record buffer? Single record buffer means whatever record you are going to read from the database, that particular records only you are going to put into the buffer. Okay, so I will note it down over here. Whatever the record you are going to read from the database, that only is supposed to put into the where buffer, not all, not all. But in full buffer, if you see here the full buffer, if you see like, but the thing is like when to use the single record buffer. This is like how the single record buffer works. When you enable the single record buffer, then what will be happen, that whenever you whatever the record you are going to read from the database, that only is going to supposed to put into the buffer. That only is put into the buffer, not supposed to put, that is put into the buffer. Okay, but the thing is, this is the behavior of the single record buffer if you are going to enable. But when to enable the single record buffer? If you are having the large table, if you have the large table, because in large table you are not supposed to put all the table data into the buffer, it will take all the memory, right? So if you are having the large table, you can enable the single record buffer if the table is not going to change very frequently, means that is going to change very rarely, right? So if you have the large table, in that case you can enable the single record buffer. If you have large buffer, then you can enable the single record buffer. So if you have the large table, then you can enable this one. This is fine. The second point I have written like how it behaves, that you have seen. And in the full buffer, if you see that all the data from a particular table is accessed very frequently, okay, and if you think, and if you see that this table is very small table, or comparatively a small, you can say a small table, then you can enable the full buffer, because if it is a small table, it will not take much memory in the application server in this buffering area. It will not take more memory, just it will take a small memory, less memory it will take. So you can enable the full buffer over there. If you see that this table is small table, then you can enable the full buffer if it is a small table. Now the generic buffer. What is this generic buffer? Okay, what is this generic buffer actually? So generic buffer is nothing but, for example, you have a table called, come over here, AC11 and MAKTX, material description table you are having, right? MAKT, in fact, F7, go to this content and run this over here, and you can see for a particular material, you can see for 23 number material, you are having the different description, right? One is test something in the different language. This table actually stores the material description in the different languages. Okay, this table stores the material description in the different languages. You can see that these are the different language. You can see the 38 number material, 38 number material in this language 5. This is some language actually, in this it is maintained like this, because this is a test demo system. Here you can see for the same material, the language is J, and it has been written in a different way. Here the language is R, maybe Russia, I don't know, and there you can see how it is written. So if you want to see what is the value of P, R and all these things, what you can do, you can go and you can press F4 over here, and you can see that the meaning of all those actually you can get over here, right? You can get from here all the meaning of that particular value. Okay, press F8, you can see. So if you want to get, like if you see that some record like 38 number record, today this particular material is going to be more frequently used, right? This material is going to be used more frequently. So for this particular material, you can enable the generic buffer. So what will happen? So if in where condition, in select query, if we are going to put this material for the where condition, all this description, right? All this description in the different languages will also come over there. All the description in the different languages will also come over there. All the description if you enable the generic buffering. So like if we're just going to write something like, I will just tell you over here. So generic buffer, if you have the select query something like this, select star from MAKT, right, into some table IT underscore tab. This is the container where only the matter is there. Matter in where condition you are having some matter, and here the material number may be 38, I can give. Okay, so if you have the select query something like that going to frequently used for the particular table MAKT, so generally this generic buffer is going to enable for the text table, right? This is also MAKT is a text table. Okay, so for this particular material there are a different, in the different languages you are having maintained the description over there. So it will take all the description and put it in the, and it will put into this particular value from the buffer itself, right? So that's the benefit of the generic buffer. In the full buffer, you want to store the buffering concept over here. If you have any doubt over here, this single record buffer, and just one thing, like when it will get triggered. So whenever you write the selector, if you have enabled the single record buffer, and if you write select, the star or whatever, a single anything, if you have written any select query from, maybe suppose you have enabled some table over here, table, and in where condition you have given some material or some key field, and that value over here if you have given anything. So that particular record, so first time when the select query will run, and if the system will see that particular table single record buffer is enabled, that particular first record will go and put into the buffer whenever the system will see this particular query. Similarly, for the generic buffer, whenever such kind of query will be seen, it will select the relevant record and it will put into the buffer. For the full buffer, again, any kind of query if you are having, whether this kind of or this kind, any kind of query, if you have any kind of query, and if you have enabled the full buffer, what will do, total record from the table it will put into the buffer, any kind of query it is. Okay, so this is all about buffering. So buffering we have completed. Please feel free to ask any question. Maybe you may get some doubt, so just please ask the question in order to get it clarify if you have any doubt. Okay, any doubt? Okay, so
Hello.
I believe there is no yeah.
Hello, sir. This is Shiva.
Mhm.
Sir, in the real time, what is the percentage of using this buffer concept in the real scenario?
In real time, generally, like when you are having the performance issue, means it's
Yeah.
very rare. This also is very rare, you know.
Yeah.
This also is very rare. Like SAP generally use such kind of, a standard
Yeah.
concept. But in
Yeah.
our scenario, like if in some project where the performance is very critical in that
Yes.
case, because if there is a standard table already, SAP has taken care, right?
Yes.
If that is the standard table, SAP has already taken care. But if it
Yeah.
is going to be a custom table, so custom
Yeah.
table, and if you think generally it is a very less chance that you are having,
Yeah.
large amount of data in the custom table, so
Yeah.
and the performance issue come in case of custom table,
Yeah.
so generally we don't use, but sometimes if it comes, we can use this concept in coordination with our SAP data administrator people, in coordination with our team lead. Okay, so
Yeah.
means we are not supposed to use directly, buffering concept without any coordination, because it can give you the
Okay.
wrong result, or because the regular like regular watch is also important, like whether the buffering is syncing or not, right? If
Yeah.
suppose your buffer is not syncing with this database table,
Mm.
then you will get the wrong result, right?
Generally, yes.
Yes,
Yeah.
so
And
that's why.
in my example, in my table, I have one Z table. I have stored the data around 38 lakhs.
Right.
In this scenario,
You
is
can
it
enable.
is it buffering concept is useful for me or not?
Yes, it's going to be useful, but you have to contact with your database administrator first, because
Okay.
yeah, you have to just you talk with them, you
Yeah.
tell that you want to enable the buffering in order to get the performance,
Mm.
and because that is the large table, what you can do, you can enable the single record buffer, don't enable this full buffer, otherwise it will take
Okay.
all the memory. Okay,
Yes. Yes.
so again it's going to hamper the performance. If you know that some particular record is only going to access more frequently,
Yeah.
right?
Yeah.
If you know that some particular record is only going to get more frequently during your daytime, or 2 days, 3 days, then you can go for the single record buffer, or maybe you can go for generic buffer. But generic buffer, I think this also, like in your case, I don't know how the structure of your table is. Maybe you can just give me the structure on WhatsApp or something like
Yeah.
that. I will see the
Yeah.
structure of the table and then I can suggest you, because the generic buffer generally we use where in kind of text table, and wherever we have to get some generic record frequently, there we use
Yeah.
the generic buffer. Okay, so
Yeah.
in your case, full buffer I will not recommend it at all, because your
Yeah.
table is large. 38 lakhs record is so much record, it will
Yeah.
take all the memory of your application server. You
Mm.
are supposed to use single record buffer, okay, if
Yeah.
some of the record is going to get frequently accessed. Okay,
Yeah.
anyone is having any other question?
Yeah, Pankaj,
Mm-hmm.
can you please send the videos, recorded videos?
Yeah, yesterday I have sent you, right?
Yeah, we received.
Okay.
Yesterday, I don't think I received.
Okay, fine. I will send you. Maybe you have missed in my that email list. I will send you. Okay.
Hello, sir.
Okay.
Mm-hmm. Yeah.
Sir, this is Ramesh.
Yeah, Ramesh. Yeah, please go ahead. Yes.
Sir, I have doubt. What is this text table, sir? What
Okay.
it is different from other table? May I
Good.
know?
Good. Yeah. Yeah. Sure. Sure. Yeah. So such kind of question I expect from you people. Okay. Like particularly from fresher, if you so don't hesitate. You can anytime ask. See, the text table is nothing but which stores the text information. For example, we are having a Mara table. So if you go into the Mara table, you can see here you are having the material number. But what is the meaning of material?
Okay.
What is the meaning of this material? There is no meaning of 17, 21, 13, all these things. Simply there is no meaning of this number. So if you want to understand the meaning of this material, whether this is a laptop or whether this is a car or whether this is a gun or whether this is a bullet or whatever this is, what is the meaning of this material? So what you will do, you will copy this material number, whichever the material you want to see in the description. Maybe I want to see the description of this material. So there is a text table actually. So from where you can get the text table, you can go to this go to, okay, and maybe utility somewhere. From here also actually we get the option to go into the text table. Check it. Go to okay, we are having the transaction called SC16N. Okay, so come over here, and here you can see that Mara table is there, and corresponding to this Mara table, MAKT table is coming as a text table. You can see here, right? MAKT table. So whatever the material you are having, you can directly go to SC11. You can copy the material. I have already copied, and you can go to MAKT table. You can go to the content, and you can paste those material over here, right? And you can execute it, and you will be able to understand what is the meaning of that. So 17 number material is nothing but the test material someone has created for the purpose of a test. So it may be any material, okay? But in real time, you will not get something like test material. You will get something like laptop, motorcycle, or whatever, or any kind of material, iron, rod, some chemical related. It can be any kind of a material. You can see here someone has given antenna assembly. So this is a kind of
Yes,
antenna,
sir. I can see that fine
antenna,
rope.
ventilation, right? So this is the text table which stores the material specific description, material specific text in the different languages. Okay, understood?
Okay, sir. Yes, sir.
Okay,
Thank you.
fine. Okay, no problem. Anyone else? If anyone is having
Hi
any other
Pankaj.
question, yeah,
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 hi
please.
Pankaj Ajit here.
Yeah.
Yeah, I have one question. Suppose I'm activating full buffer. Okay.
Mm-hmm.
So in
Mm-hmm.
that case, suppose I'm writing a query like select a star from a table 1 into table 2, and also I'm writing the where condition there. Okay, where ID is equal to 38 something.
Yeah, it will consider the full buffer. All the data will get and store into, though you have written the where condition, and you were thinking that it will take that particular record only. So that particular record only will come into your internal table. But in buffer, for the very first time, all the record are if the system will see that it is a full buffering activated over there, it will take all the data and it will put into the full buffer. So it is independent of where condition. That's why I've written over here that any kind of query, and if you are going to hit any kind of query and full buffer is activated, it's going to take all the data and going to put into the buffer area. It's clear?
Yeah. So internal table
Oh,
and buffer, both are the different thing, right?
yes,
We are
yes, yes.
putting, so
Internal table and
suppose,
buffer is both is different. Yes.
right. So actually, putting the data into an internal table, okay,
Mm-hmm. Mm-hmm.
it will take the data from the buffer itself, right?
No, no, no.
So,
If you have enabled buffer, then it will take the data from buffer. If buffer is not enabled, the select query will go and hit the database layer, and from here it will fetch the data and put into the internal table. If buffer is enabled, then system will check for this particular table if buffer is enabled or not. If buffer is enabled, then it will go and take the data from buffer. So
okay,
buffer
so
is the buffer is the memory area created at the application server layer itself. Application server is also is nothing but a computer, a large computer, right? And there also is having some memory. So in that memory, this buffer is going to be created, right?
okay, so automatic syncing of the change record is happening on regular basis on this buffer table, right?
Right. There is some, that's why like you have to get in touch with the database administrator, and they will guide you like if this particular table is suitable or not. Means both in coordination you will have to decide, because after 2 minutes or after 5 minutes or after one day when the record is going to get synced, or it is a event based syncing over there, like whenever the record is going to change in the database layer, at the same time itself, without getting any delayed, the buffer starts syncing, right? So that's why like you have to take like if it is a large table, you have to be very very careful. Even we are not supposed to use without means proper understanding. Okay, so just mostly I have covered this topic not to use in the real time, mostly from the interview point of view I have covered. So in real time, if you want to use, you can use, there is no problem at all. You have to consult with your database administrator, but mostly like this concept you should understand in a better way in order to appear effectively in the interview. Like if you want to, because they actually want to understand how much good you are in this concept or not. Suppose sometimes if you require to use this one, will you be able to use or not? Okay, so you can use, there is
Right.
no issue, but this is the things you will have to take care. Fine. Any other question?
Yeah, okay, thank you.
Okay, so if anyone is having any other question, you can go ahead and ask. And tomorrow we are going to see the append structure. What is append structure? Okay, what is customizing a structure? This we are going to see. Then we are going to see the include structure. So these important things we are going to see tomorrow. Okay, and tomorrow also the table portion, I think it's completed now. And also we are going to see like the what is the difference and all, we are going to see. And then we will see the different database view, different view actually. Okay, so this is the tomorrow. If time permits, maybe we can go a little further and we can see about the search help. Okay, so let's meet tomorrow. For today's, I'm just going to stop over here. Okay, so thank you very much. Thanks a lot. Let's meet tomorrow. Bye bye. Have a nice day.
Bye bye.
Thank you, sir.
Hello.
Yeah, yes.
Sir, today assignment anything have you done? Is there assignment?
Today there is no assignment. Okay.
Okay.
Today, like, yeah, today there is no, only the thing, just go through the video and try to understand this concept and try to explore from internet also, because this, this concept is very, very important concept. And mostly like if interviewer asks, the people gets stuck because the people is not able to remember such kind of concept. So if you understand the concept, you will be able to remember. So understanding is very, very important. Okay. Okay, others.
So
Hello.
yeah, okay, sir.
Yeah, so this is understanding is very important here. I don't think so. If you want to create the full buffer and all these things, you can try and create in your system, and you can see how the performance is going to like how it's performing. You can try yourself. Okay, because everything in detail it is not possible to cover. Maybe I will prepare a separate video like how is going to improve the performance when you are going to create the, when you are going to uh, enable the buffer. For that I can prepare some series of videos, and in that I can show you, you know that how you can decide the buffer to enable or not, what is the pros and cons in the real time by giving all the things in the by demonstrating all the things. For that I can show you. But if I'm going everything in detail, no, here it's this particular data dictionary itself will take a lot of time to complete. Okay, so just you understand the concept over here, and once everything gets completed I will prepare the video and share on the YouTube. Okay, fine, then let's complete over here. Let's end our session over here. If you have any query, you can also ask on my WhatsApp, okay, or you can send me an email. I will reply over there. Okay, so thanks a lot. Bye bye, have a nice day.